If you remember from the last lesson, there was this word problem at the end that was kind of a little pain to graph because it had really large numbers, and actually one of the intercepts was a decimal. So we had to estimate where that was. We also had to kind of guess where the intersection point was. So there are other techniques. One of them is called substitution. The way that you do substitution is as follows. You solve one equation for either x or y. Now, if there are other variables, then you would just solve for one of the variables, but the traditional is going to be x or y. Then you take that expression and you plug it in by substituting it into the other equation. And then you solve for the variable. Then you take your answer and you substitute it into either of the equations. Might sound like gibberish right now, but once we do an example, you'll see what it all means. Now, if you look at the equations, this is written in slope-intercept form. It has the y by itself. This is written in standard form. But when you're doing substitution, as long as one equation has a variable by itself, then you can use that technique. So if you notice, the y is by itself over here. So what we're going to do is we're going to take negative 2x minus 9, and instead of y down here, we're going to squeeze in negative 2x minus 9, because if y is equal to negative 2x minus 9, then wherever I see a y, I can put negative 2x minus 9. So what we write is this: 6x minus 5 times negative 2x minus 9 is equal to negative 19. So the only thing that I did was I took this thing that equaled y and put it in the spot for the y. Now it's just an equation straight out of chapter 1, so we just distribute and combine like terms. So I get 6x plus 10x plus 45 equals negative 19. That, keep going. I'm going to subtract 45. Gives me negative 64, and so I know that goes in 4 times. So the x value of my intersection point is negative 4. So I have half of my answer right now. I just have to find the other point. So the way that you do that is you take negative 4, and in either of the original equations, you plug in negative 4 for x. So you can pick whichever one you want. I usually like to pick the one that looks simpler, because if I get to pick, hey, why not? So I think that the first one looks simpler, so let me do that. Y equals negative 2 times negative 4 minus 9. That gives me 8 minus 9, which is negative 1. So the y value of my answer is negative 1. So I'm all done. This is my answer. That's the intersection point. One way that you can check is you take negative 4, you plug it into the other equation, and you just make sure that you would also get negative 1 out of that equation. A little extra step down in example 2, you will notice that neither of the equations have a variable by themselves. They're both written in standard form. So when that's the case, what you do is you pick one of the equations and you have to move something around to get a variable by itself. So there's a couple options. I can add x in this first equation to get the y by itself, or I can take the second equation and move the 3x over to get the y by itself. You don't always have to get the y by itself, but in this case, it's simpler. So it doesn't matter. I'm going to do the first one. So if I add x to both sides, I know I'm writing it on top when we usually write it on the bottom, but if I add x to both sides, I will just get y equals 3 plus x. Now that the y is by itself, I can take it and plug it into the other equation. So instead of y, I can put 3 plus x in the y spot. All right, so here we go. 3x plus 3 plus x equals -1. All I did was instead of y, I put 3 plus x because that's what y equaled. Now you just combine like terms, so we get 4x plus 3 equals -1, and then you just solve, no biggie. I got my x value is -1. So I have half of my answer. Now I'm going to take -1, I'm going to pick an equation, and I'm going to plug it in. I'm actually going to pick the second equation because I would prefer to avoid having to deal with this negative coefficient for the x. But again, it doesn't matter. So 3 times -1 plus y equals -1. So that gives me -3 plus y. Then I add 3 to both sides, and I get that my y value is 2. So the intersection point is -1, 2. All right, here's a word problem. Pause the video, read the paragraph, and play when you are ready. All right, so I underlined and highlighted a bunch of things. So now I'm on to my plan phase. Now the plan is actually down here at the bottom. It's actually almost basically all spelled out for us. So let's look. They told us that we're going to do 64 times the adult ticket price plus 132 times the student ticket price because that's the information that they gave us up here in the story. 64 adults, 132 students. The one thing that they didn't do was they didn't define their variables, so we have to do that for them. So it looks like let's make adult ticket price x. So if x is adult ticket price, then y is going to be student price. And then we can write the equations 64x plus 132y equals 1040. And then the other equation, adult ticket equals 2 times the student ticket, is going to simply be x equals 2y. Now you can see this is set up for elimination because it has a variable by itself. So what I can do is I can take 2y and plug it in right here in the spot for x, because wherever I see an x, I can put 2y. So let's do that. 64 times 2y plus 132y equals 1040. That gives me 128y plus 132y. And now I just have to add. That is 128 plus 132 is 260. 1040 divided by 260 is 4. So since y equals 4, that stands for the student price. Now I have to get the adult price. So I think the second equation looks way easier. X equals 2y. So just plug that in. X equals 2 times 4. You probably could have even done that in your head. X is 8. So that's the adult price. So let's go back up to the question. We had to write a system of linear equations. We did that. What is the price of each type of ticket? So we're not going to write 8, 4 because that sounds like you're from another planet if the question says, what are the prices? So we have to say $8 per adult and $4 per student. If you have any questions, write them down and ask me when you come to class.